Hi, everyone. Thank you for taking the time to be with me today for this talk. My goal is to give you some useful information about the Amazon EC2 instances where we feature AMD CPUs. A little bit about myself. My name is JD Koos, and I've been building and working with servers, storage, and networking for about 13 years while at Hewlett Packard, at Cisco Systems, and then Broadcom, and then just within the last year, now at AWS. I have a very strong passion towards building more efficient infrastructure and helping customers to take advantage of it. Currently, I am the product marketing lead for EC2 instances where we feature AMD CPUs. So we're actually a very small team and we're focused on the core of EC2. So let's go ahead and get started. This is an interesting picture I always like to start with and spend just a brief minute on. And Gartner's actually very particular when it comes to the methodology they use for the axes on the quadrant here. From my perspective, if innovation and execution are able to go hand in hand for a pretty sustained period of time, then one organization is able to do well on a magic quadrant. And in the case of EC2, I think the breadth and the depth of the offerings, the speed of the delivery of the innovation, the size of the community that's helping us to improve the product, and then the maturity of the product set are really what allows AWS and specifically EC2 to have this position for infrastructure as a service. In the discussion today, I hope to get you excited about some of the new innovations that have recently come with EC2, what we call the Elastic Compute Cloud for AWS. So what does Amazon EC2 look like today? Well, for all sorts of different workloads, ranging from a single server test environment where a developer just wants to see how the code runs, all the way to massively scaled up or scaled out infrastructure that powers critical infrastructure such as self-driving cars or bank transactions. We offer different capabilities that match application needs. So all the options that you see here, which we won't read one by one, from all the way from essentially a very GPU dense environment or to leveraging local FPGAs to ARM powered instances to a single instance with up to 24 terabytes of local memory to network speeds ranging from 1 gig to 100 gig and access to nearly unlimited storage capacity that is what we call high performance block level storage with the Amazon Elastic Block Store. So you can run, because it's block level access, you can literally run any storage stack you want at any scale and see the kind of performance that you would expect based on the storage stack that you've chosen. And all these options really create what we think of as the power of choice for customers, so that customers can choose EC2 instances that are meant to really match the business needs. So as we go forward today, we're going to talk about a subset of really the over 300 instances. It's now, I think, just over 350 instances that are available within EC2. We're going to talk about the subset that really are focused on and feature the AMD EPYC processor line. So if we think about categories of EC2, some of the most popular are going to be the categories of the compute optimized, the general purpose, and the memory optimized categories of EC2. The instances are built to give you a broad kind of category options, yet when you drill down into each, you'll see that within each, you can right size your instances to a very granular level. And customers actually have asked AWS to give them more choices for processors in the last few years. And specifically, there has been a lot of interest today and in recent years in leveraging the AMD EPYC line of server CPUs. So if you look at these three categories of EC2 instances, you'll see that the AMD EPYC line is mapped to a number of the different very important and kind of high usage and highly relevant sets of EC2 families. So as we go forward, let's dig into some details about how we can actually go ahead and leverage EC2 instances where AMD EPYC processors are featured. So if we look at the instances where we include AMD processors, there are a couple things, or a few things that really stand out. First, when Amazon finds a way to build a high quality product where we're able to also offer it at a reduced price, our goal is always to pass those savings along to customers. So what you'll find is that the EC2 instances where we feature AMD processors are available for a reduced price when we compare them to previous generation comparable instances. And another benefit that AWS is able to offer to customers is the ability to define their instances based on a broad variety of processor choices. So specifically, EC2 instances are today offered with Intel Xeon x86, AMD x86, as well as Graviton 2 ARM-based CPUs. And there's one more feature of the AMD instances that I think is noteworthy. It's that we have this very strong focus to make the experience very simple for customers. And towards that goal, what you'll find is that if you're using, as an example, the EC2 C5 instance, which is an instance that's been around for a couple of years now, if you're using that C5 instance, it's very easy to migrate to a C5A, the A being the AMD processor variant version. The same would go for a transition from M5 to R5 and T3 all the way to M5A, R5A, and T3A respectively. So customers have told us that the ability to make these transitions easy is very important, especially that the sizes of the instances be very similar. And so we've gotten very good feedback on how quick the transition is to make a move from any one of these previous generations to the new ones. And we'll talk more a little bit in a few minutes about some customer success stories where customers have really felt that simple transition. So one really good place to start in looking at Amazon EC2 is the general purpose instances. So let's get started there. Now, the general purpose instances where we feature AMD processors, they're available with what we consider a balanced ratio of memory in gigabytes to compute in vCPU at a ratio of 4:1. And they're a good fit for a broad variety of workloads. Now, specifically, the EC2 M5A instances, they utilize the AMD's first generation EPYC 7000 series that runs up to 2.5 gigahertz. That generation is actually known kind of in the industry as the Naples generation of x86 server class CPUs. The M5A instances, they have high network bandwidth as well as throughput to the Amazon Elastic Block Store, or EBS, which, as we mentioned earlier, is the high performance block level storage that's designed for use with EC2 all the way up to unlimited scale. The M5A instances, they're also available, as we mentioned earlier, at a very granular set of sizes. You can actually have them all the way across 8 different sizes with local NVMe and 8 sizes without local NVMe that would just have access to the remote EBS block storage. And so that's a total of 16 different sizes that you can choose once you drill down within M5A. That way you can right size the application and really right size the infrastructure for the application. So really thinking, kind of moving past the general purpose instances, they have a very broad application for a lot of different use cases. But there are very specific times when it's difficult to know what your instance and what your compute infrastructure, what the utilization is going to look like. It can be very unpredictable. So let's take a look at another kind of EC2 instance where we can get AMD processors with a very specific and unique use case. So as most know, any who have kind of looked backwards and tracked CPU utilization rates over a historic period, we know that some applications are going to be relatively predictable. You're going to see some trends. You're going to see maybe seasonality, or you're going to see monthly kind of work. processes that happen, or you're going to see spikes in certain times, and you may see trends. And therefore, in the future, it may be possible to predict kind of how you want to size. But for some workloads, specifically ones where you have a low average utilization rate, such as the case, if we were to imagine in this chart, this might be 6 months of time, let's just say, the actual average here is very low. It would be just above that baseline there. But you have these occasional very, very high spikes. So what would you do if you were going to spec an on-premise system that was going to attempt to handle these spikes? Well, in the case you really needed to solve for the highest common denominator, you would end up with a system that was very, very inefficiently built and would be on average significantly underutilized. So this is kind of something I think most folks have seen in the past, and it's a relatively difficult problem to solve, or has been, until the introduction of the burstable instances from EC2. So we call them T3, in this case T3A, featuring AMD. And so the T3A instances, they're called a very, very low cost on average general purpose instance type, where a base level amount of CPU is provided, but you have the ability to burst very, very far above the baseline. So if you know that your bursts are going to be potentially very large and very sporadic and very unpredictable, then why pay for that very high utilization rate all the time? Pay for it only in those times when you really are having those spikes. So if we have workloads that we consider unpredictable and occasionally very spiky, the T3A instances, they give us really the best efficiency for our spend. These instances, they're available for very low cost per hour of usage, and you truly, when using T3A, you truly are charged for only the compute that you're using. So another thing we've heard over time from customers is that some applications require very high, kind of a high ratio of memory to CPU, sort of a different ratio of CPU to memory than our general purpose instances. So that's why we created a category called memory optimized. Now, with the R5A instances, again, R5 being 5th generation memory optimized and A being for AMD, these instances, they have a ratio of 8:1. If you remember, the general purpose instances were a 4:1 in terms of gigabytes of DRAM to vCPU. And so now we have twice the amount of DRAM per CPU compared to the general purpose instances. And this, of course, is for applications that really can benefit from having that additional memory footprint. So the R5A instances, they actually feature, just like the M5A, they feature AMD's 1st generation Naples processor, and they're available in 8 different sizes that feature local NVMe and connection to the Elastic Block Store, and then 8 sizes with just the connection to the Amazon Elastic Block Store, for a total of 16 different options. So the instances these would typically be used in kind of our ideal fit for applications such as analytics, in-memory databases or caches, and for enterprise applications that require a lot of DRAM, such as SAP apps, Oracle, or SQL Server, and other high-performance databases. So sort of on the flip side to the memory-dense instances, some workloads actually, in general, require less memory and require more compute in terms of a ratio. So enter the C5A, compute optimized instances, where we feature AMD processors. So these are built for compute intensive workloads, and they're the most recent addition to the family of EC2 instances where we feature AMD EPYC CPUs. The instances, they feature a memory to vCPU ratio of 2:1. So now we're twice as much compute in the opposite direction of the M5A general purpose instances. So instead of a 4:1 ratio, now we have a reduced amount of DRAM relative to vCPU. So these instances are based on the 2nd generation AMD EPYC processors, the 7002 series, that run up to 3.3 gigahertz. And these are kind of known colloquially in the industry as, under code name, the Rome generation of EPYC CPUs. So the C5A instances, they feature, just like M5A, they feature high-speed networking and storage access to the block store, and they're available, similar to the other categories, in 8 sizes with local NVMe storage and 8 sizes without local NVMe storage. These instances are a really good fit for applications such as gaming, log analysis, something like batch processing, certain web applications, and distributed analytics, just to name a couple. The C5A instances, they offer a price performance benefit compared to comparable instances, and actually they represent the lowest cost per x86 vCPU in the entire EC2 family. So how do we go about choosing between the instances? To take kind of a summarized look at the various ways that we can leverage AMD-based EC2 instances. Well, first is always good to mention that a local solutions architect or a field sales representative is always available to help assist in right sizing. There are also on the AWS website a number of tools that we can use to help to analyze a workload today, whether it's just based on the application type, based on the systems that are being used today in terms of specifications, or even if you have information about past utilization rates, you can kind of use a number of different ways to determine how you think you may want to implement on EC2 going forward. And then I think another thing very important to mention is that even once you deploy and you're in production on any EC2 instance, it's very easy to use something like auto scaling to scale reactively. In other words, this is a tool that will sense that we need more power in a particular direction or more compute in a particular direction, and we will scale up and down. And then we can also kind of proactively go in and use tools to change the amount of compute that we have allocated, as well as changing between instance sizes is a relatively straightforward process, or I should say changing between instance types. So to kind of recap of the kind of instances you can choose from where the AMD EPYC line are featured, the M5A, they're the general purpose instance and they have the balance of the compute, memory, and network resources, a very popular set of instances. The T3A are the Burstable, where they're a great fit for when you really don't know when you're going to have potentially very significant and very sporadic spikes in CPU needs, but spikes that don't happen too often because you do pay when those spikes happen. So your goal is really to know that these are going to be sporadic spikes. The R5A are designed with a very high ratio of memory to CPU. And then the C5A are optimized for compute-heavy workloads, and they have the very high ratio of compute to memory. So all the different instance types are available in a broad range of sizes and specific configurations. So once you click into the options and you start to look at each size, you can really run the application that you need to run in the most efficient way. So let's take a look at where you can find EC2 instances with AMD processors today across the global AWS footprint. So EC2 is available today in 24 regions and 77 availability zones. And I think it's pretty remarkable, 216 today points of presence, or POPs, as some people call them. They're also sometimes referred to as edge locations, and they're built for extreme low latency needs. The global footprint of AWS is really one of the reasons why in a recent third-party non-commissioned study, EC2 saw 1/7 the amount of downtime as the closest competitor. So when we really look at the AMD-based instances, they're being expanded very, very, very regularly. At this point, almost every month, we're adding new regions, and therefore within those regions, several new availability zones all the time. In fact, just in August, we rolled out availability for the C5A instances, the newest compute optimized instances with the second generation processors from AMD EPYC across 7 additional regions. So one thing that's definitely for sure, and that I believe will continue to be the case, is that this slide should become outdated pretty soon. So you can take a snapshot of where it is today, but we keep on the website and within the console current data about exactly which regions, which availability zones, and which POPs are currently online. So one of my favorite things to do is to think about what customers are able to do with the technology. So that game company, they're known for making very visually stunning video games. They recently went through a migration from the EC2 C5 instances over to the C5A, where AMD processors are featured. And they experienced something that we really hope and we tried to build into the solution. They experienced this very seamless transition where they were able to both gain performance advantages, as you can see here from what Peter Lee is saying, performance advantages and saving cost. When a customer is able to see performance benefits and save costs and make the transition to the platform very easily, that's something that just puts a huge smile on my face. Now, Wego is the leading destination for online travel commerce in Singapore. They also just made a transition similarly from C5 to C5A. Like that game company, it was a very important app. In fact, it was their largest scale application that they made this transition for. And Wego told us that there was no code changes required. What they consider to be a very minimal lift and shift, and they said the transition was completed within just a couple of days, as you can see from what Gary has said here. And this, as we said, was their highest scale application, compute dense application, which requires today a very large footprint. In fact, they were able to have such a performance benefit that they had a very significant reduction in how many instances they needed to deploy in order to be able to run at that same performance level that they thought was part of their SLA. So there are quite a few stories similar to this, and we don't have time to go through many, but I do have to say I take the most pleasure in knowing that really the innovation that our team is driving towards is able to give customers real benefits. So let's summarize the things we've covered today. The C5A, M5A, R5A, and T3A instances where we feature the AMD EPYC line of CPUs, they offer customers 10% lower prices, which helps you, of course, optimize your budget spend so you can reallocate into other kind of more interesting and innovative areas. And a core tenet of AWS is customer choice. So with the addition of AMD, you now have 3 choices for CPUs within EC2. That's Intel Xeon, Amazon Graviton 2, and then AMD EPYC lines of CPUs. So the C5A, the R5A, and the T3A instances, they offer similar virtualized sizes as the C5, M5, and R5, and T3 instances. So we consider them to be application compatible from a transition perspective and should offer a very seamless and quick transition from one generation to the next. And so in general, the latest generation of instances with AMD EPYC systems, they offer lower costs. And for some workloads, you're really going to see lower costs and higher performance, which in this case would allow you to do more than you could before with even less budget. That way you can refocus budget. I want to thank you for taking the time to listen in today. I hoped I helped you learn a little bit more about the Amazon EC2 instances where we feature AMD EPYC processors. Thank you again.